Good morning, everyone. My name is Kyungmok Kim, and today I am pleased to present our study titled Studying Machine Learning Models for Forecasting Macroeconomic Indicators. This research was conducted in collaborations with my co-authors. The name is Landong and Nok Tri Trang, Bun Pham, and Hanam Ingyen. In this presentation, I will walk you through our objectives, methodologies, findings, and potential future research directions. Uh, Today's presentation outline is as follows. And this slide, accurate forecasting of macroeconomic indicators such as GDP, inflation, unemployment rate, and exchange rate is crucial for policy planning and economic decision making. Traditional models like ARIMA have been widely used, but they struggle to handle nonlinear and complex economic data. With the rise of machine learning, new opportunities have emerged to improve forecasting accuracy. Our study investigates the effectiveness of machine learning models in predicting macroeconomic indicators and compares them with traditional approaches. In this slide, our research has been main objectives. The first is to apply and compare the performance of machine learning models in forecasting macroeconomic indicators. The second is to identify the suitable model for each economic indicators. The third is to evaluate the averages and limitations of each forecasting approach. By achieving these objectives, we aim to contribute to the improvement of economic forecasting techniques. In this study, we used data from the World Bank covering the period from 28 to 2023. The dataset includes 11 Southeast Asian countries. We consider these macroeconomic indicators such as GDP, inflation, unemployment rate, and exchange rate. Data processing steps improved handling mixing values, removing outliers, and normalizing the data to ensure accuracy and consistency. We analyzed both traditional and machine learning models for economic forecasting. Traditional models such as ARIMA and linear regression, machine learning models such as random forest XGBoost, LSTM, and SPM. To evaluate model performance, we use the following metrics: mean absolute rate, root mean squared error, and R squared. Now, let's briefly discuss each model. Linear regression assumes the linear relationship between economic indicators and their influencing factors. It is simple and easy to implement, but it lacks the ability to capture complex and nonlinear patterns in economic data. The general formula of the linear regression models is on this slide, where Y is the macroeconomic indicator, X represents independent variables, and beta are the regression coefficients. And ARIMA or the box Jacqueline's method is a traditional time series forecasting approach that includes AR using past values, I removing trends, and MA smoothing out fluctuations. While effectiveness of for structures time series data, ARIMA struggles with large fluctuation and nonlinear economic trends. In short-term memory, LSTM is a deep learning-based recurrent neural network designed for sequential data. It is well suited for long-term economic forecasting. However, LSTM requires a large dataset and extensive computational power for optimization. Despite its potential, LSTM's complexity makes it challenging to implement compared to other models. SVM is a powerful classification and regression model that finds the optimal hyperplane to separate data points. It has potential in economic forecasting, but requires careful parameter tunings. While SVM can handle complex data patterns, its performance values depending on the dataset characteristics. Random forest is an ensemble learning technique that combines multiple decision trees to improve accuracy and reduce overfittings. It performs well with nonlinear data. It is more robust than linear models but can still struggle with highly volatile economic variables. XGBoost is a boosting algorithm known for its efficiency and high performance in predictive modeling. It optimized the forecasting by sequentially improving weak models. Our study found that XGBoost outperformance performs other models in predicting GDP, inflation, unemployment, and exchanging rate. In this slide, table shows it mean absolute error for each model across different economic indicators. Random forest and XGBoost uh, outperform linear regression. ARIMA, LSTM, and SPM. Uh, XGBoost in particular has the lowest error rate, making it the most reliable model for forecasting economic indicators. The root mean squared error across different models XGBoost achieves the lowest RMSE for GDP, inflation, and unemployment rate predictions. This suggests that XGBoost provides highly accurate forecast for macroeconomic indicators. Table present the R-square values for each model. Higher R-square values indicate better model fit to the actual data. Random forest and XGBoost consistently show the highest R-square values, further confirming their effectiveness in economic forecasting. In this slide, figure 1 presents a graph illustrating the previously discussed figures. And next, figure 2 presents a graph illustrating the previous discussed value of figures. And next, the figure 3 presents a graph illustrating the previously discussed figures. In this slide, experiments and results. In conclusion, machine learning significantly improves macroeconomic forecasting. Among the models tested, XGBoost and Random Forest delivered the best performance. The choice of model depends on the specific economic indicator and data characteristics. Our findings highlight the advantages of ML over traditional models in capturing complex economic patterns. And next, the characteristics of each result based on the experiments are as follows. In this slide, same one as before. Next slide, moving forward, we suggest um, developing hybrid models to enhance forecasting accuracy, incorporating market sentiment and ESG indicators, expanding research to other economic regions to validate the model performance. These advancements will further improve macroeconomic forecasting using machine learning. Here are some key references that supported our research. We appreciate your attention, and I'm happy to answer any questions you may have. And finally, this script provides a professional and structured way to present your research at the conference. Let me know if you need any modification or additional details. I sincerely hope that this academic conference concludes successfully. Thank you for your attentive listening. Thanks so much.